talk about some of the property of the Riemann integral. One of the first property that I want to talk about that is bounded on the closed interval a and b. Remember that these closed intervals are compact sets, and we have a partition P and a partition Q. Whenever that, all this is partition of the same interval, where Q is a refinement of P. It means that if it's a refinement, means that P is a subset of Q. Okay? Then we will say that the lower sum of the partition P for F will be less than or equal to the lower sum of the partition Q, which is the refinement. Okay? Same thing will be for the upper sum of the partition Q will be less than or equal to the upper sum of the partition P. So for this part, we have by definition, this is coming from the definition of the Riemann integral. This is the part in the middle, right? That the lower sum of the partition Q is less than or equal, whenever it is integrable, of the upper sum of the function Q, of the partition Q, right? Then let's only, in this case, prove this part, right? The lower sum. The upper sum is a homework for the audience. So let's start here. Suppose that we have a partition P defined as x1, x0 to xn, right? And consider the partition P star formed by joining some points, say x star to P, where xk minus 1 is less than x star less than xk, whenever k is a number from the 1 to n, right? So we will have, let me explain it here, maybe with the graph is better. If we have these two numbers as a part of the partition, we are adding this number in between, which is x star, that it will be some point, right? Let's call it, it could be t1 or t2. But what we say here is that any of these two numbers, t1 will be the infimum number between the first part, right? Basically, we are adding a new partition here, a new set of partition, which is this one. Or we are adding this other new partition, the other side, right? We are getting the smallest number in between of these two intervals. One for t1 and one for t2. So what we said here is that either t1 is greater or equal to the minimum sum, right? Remember that minimum sum, this m in lowercase is this one, is the infimum of the interval inside the partitions, right? Or tm or t2 will be greater than or equal to mk. So in this plot that I have here in this graph, we said that in this case, for this specific case, t1 is equal to mk, right? And t2 is not equal but is greater than mk, right? So, okay, this is the definition that I just showed in the other paper. The terms in the lower sum of P star, the partition P star, and the partition P are all the same except for this part. Everything else is the same, okay? So whenever we do this subtraction that we have here, basically every other term will be deleted except for this one. For example, what is the lower sum of P star? Will be the summatory of all these subintervals. So multiply it, right? multiplied by the space of the interval, the length of the interval, right? Because we have in this case 2, we basically are going to add 2. This one first and then this one. So for this term, we are going to add the function t, basically, is the one that we have here, multiplied by the distance of the interval. In this case, the distance is the greater than the greatest minus the smallest, right? Plus, again, the evaluation of the function multiplied by the distance between here and here, right? Minus what? Minus the lower sum of the partition P. In this case, it will be wherever is the number m, which is the infimum, and the distance of everything, right? From here to here, the whole interval. We can rewrite that in a different way. If we do the algebraic manipulation, we can put this in these terms, right? We see that this is greater than the minimum number here. These two numbers, of course, this is greater than this one by definition, and the same thing with this one. Maybe in this case this one will be, this is greater than this one, this is the same for this example, but it could be different. So one of them will be 0 and the other one will be positive completely. So, and this is the distance. So every single term in this equation is positive, right? If we have for the partition Q contains more points, let's say this is not just X star, we may contain more points of this, we can apply the same arguments again for everything. So we will have basically the proof that the lower sum of partition P is less than the lower sum of partition Q. It's less than or equal. The idea is that it come equals at some point. Right? Okay.